Welcome back to Dr. Sucheta's interactive class. Today we are going to learn one of the topic based on parameters of instrumental analysis. You might have done few practicals based on instruments. So while performing these experiments, how and which are the different steps and terms involved in this instrumental analysis are important. We are going to see all these details in this particular video. In this particular topic, we are going to cover the techniques, methods, procedures, protocols, selecting an analytical method, the term accuracy precision, sensitivity, selectivity, robustness, ruggedness, the scale of operation, means what is the amount we are going to detect if we choose a particular method, equipment, time and cost for the method, making the final choice of the method, developing the procedure based on the final choice, calibration, standardization, sampling, validation and protocols. So we are going to learn all these terms involved in instrumental analysis. Now when we say a word analysis, what actually it defines me? It tells me chemical as well as physical information about the sample. How many components present, which are the components present, what are the physical parameters of the components, identity, concentration, the different properties such as melting point, boiling point. And when we spell out the word determination, we have, if you remember, we have wrote down most of the experiments, practical experiments with the title to determine. So we want to measure one or more physical or chemical parameter in a given sample. That tells me about the word determination. When we are determining this, we have to follow some techniques, methods, procedures and protocols. Now these words might be very new for you, but if you keep in front of you the experiments, how you have performed, how unknowingly you have utilized the technique, methods, procedure and how you have followed the protocol which has been prescribed and given in a written form as a lab notebook. If you keep these things in front of you, it will be very easy for you to understand this topic. Technique is any chemical or physical principle that can be used to study the analyte. So for example, when we are finding out the melting point or boiling point as a physical constant, so what protocol or what method I need to take? I need to take an assembly utilized for melting point, like a traditional assembly made up of Thil's tube, thermometer, capillary. So I have to follow the method, I have to utilize this technique, I have to follow the method and procedure and protocol, that the heating should not be done at a one point. I need to travel my gas inlet, the burner, in a triangular position from the end of the triangle to the basement of the particular assembly. So I need to travel always, this is particular way to perform, this is the protocol to be followed. Okay. Or for the experimental techniques such as instrument like atomic absorption, where we usually determine the alkali and alkaline earth metals, where I need to prepare the solution which is of lower concentration, like in ppm, parts per million. Method. Now it is an application of the technique. Once the technique is designed, principle of the technique is known to me, like AAS is utilized to determine alkali metals. So I need to define the method that will tell me the exact concentration of metals present in a sample solution. So it is an application of the technique to determine the specific element present in a sample. To determine that specific element in a sample, I need to write down the procedure which will tell me that stepwise, yes, for determining the alkali metal concentration by using AAS, first, if the concentration of alkali metal, for example potassium, I need to determine, then I need to prepare first the standard solutions of potassium. I need to determine the absorbance measured by AAS for these all known concentration solutions, so that I will have a calibration plot, and then I can go for unknown solution. So procedure is a set of directions detailing how to apply a method to a particular sample, including information on a paper sampling, handling of interference, and validating the results. So a method does not necessarily lead to a single procedure. So even if I change the analyte from potassium to calcium, then same procedure I need to follow. So finally, a protocol which has been set up to follow the method to be done on a particular technique or instrument is a set of stringent written guidelines to be followed. So protocols are commonly encountered when analytical chemistry is used to support or define a public policy. So in terms of, there are different acts are there, like Environmental Protection Agency, IPR. So these all norms, when you are coming in these all standard public norms, you have to follow the protocol. For example, if your company is dealing to sell the water, you have to follow the protocol of water, which tells me the specific limit for the presence of the metal, lowest concentration of the metal to be present or to be allowed to sell in drinking water. So here these acts are given with a stringent protocols. That protocol I need to follow when I am developing a particular method. So selecting an analytical method sometimes become a difficult task. Like for example, if these are the elements for which I am just finding out the method which to be followed for a determination of the sample. So if these are the different elements present in my analyte, or suppose we will concentrate on only one element like Fe. So Fe can be determined gravimetry, Fe can be found out by AAS, Fe can be found out by complexometric titration, Fe can be found out by coulometric, potentiometric or voltammetric titration. So if for a particular metal, suppose these are 4 methods available, now which to be chosen, so that is the task suppose given to you, that you are being appointed in a QC laboratory, analytical chemistry laboratory, and a task is given to you that you have to choose a proper method to find out the concentration of one of these elements present in a analyte. So you will search for the methods which are there in reference books, and you will find out, and there are n number of methods like here 4, 5 enlisted methods you will find out. So how to choose a particular method for your sample. Now here, when you are performing the analysis, you need to report the data in terms of specific statistical terms like sample, which is nothing but set of measurements. When you observe the readings for particular analysis, the average of the reading is defined as mean, and the term true value relates towards some standard you utilize, or for something which is for some particular method when you want to follow, you want to check it out whether it is giving me the correct result by the instrument. So the true value or the known concentration is known to you. In that case, I can utilize the term true value. And when I am performing any analysis and observe the data, that is observed value. So any particular method can be differentiated in between these two statistical terms, accuracy and precision. When you perform the experiment and your experiment is very close to the true value, then your accuracy of the method is very good. And precision is the term utilized when you are unaware of the amount or the true value, and you are providing, you are performing the experiment, and repetitively you are getting same results. So the degree of agreement between replicate measurement of the result can be given by precision. So these are the terms we have learned actually during our second year BSc course, and these are much aware with this just imagine a dart model, arrow and dart, that particular game, and three particular students suppose are playing this particular game of dart with the arrow, and one student is hitting the this particular game. The answer is known to you that you have to hit at the center. So the first student is hitting at the center of the dart, second one is unable to hit at the center, but his arrow is hitting at a specific point again and again, whereas the third one who was trying to play this game and randomly his arrow is touching to this dart model here and there. So what about these three figures? I can say that the first one tells me that yes, because in this case the true value or the exact result expected by you is the center. So what you can say about the observed results, they are very much close to the true value. So this particular person is, or the readings are more accurate as well as precise. In second case, the result is not accurate. The person is performing and repetitively getting the same result. So the method or the results are precise, and third one, they are neither precise nor accurate. This we can express in terms of absolute error, differentiation between the observed value and true value, and if we take relate with the true value, we will find out relative error, and we same can be expressed in terms of percentage by multiplying 100. Whereas this particular results, we have to take care of the sign. If it is positive, if it is negative, you have to interpret your results with the same sign. Whereas yes, here is an example. Whereas precision, here you are not these results are not necessary to express, or they are expressed without regard to the sign, as it is deviation. So we can express the result of any particular method in terms of precision as deviation, standard deviation and relative standard deviation, where we need to know mean of the result and observed readings. This is the mean of the result and these are the observed readings. So you have to find out the difference between them. Average deviation is summation of squares of deviations divided by number of observations, whereas standard deviation is square root of summation of squares of deviation divided by 1 less than the number of observations. This is the example I have given. Yes, again back to the instrumental analysis. We usually utilize this term sensitivity. Whether my instrument is sensitive towards the result. Now how it is possible for me to define this word sensitivity? Now this can be very finely defined, where suppose you are performing experiment on colorimeter. So colorimeter is the instrument designed based on Beer's law, where you measure the absorbance of colored solution, which is valid for lower concentration. Now if any colored solution you pick up and measure the absorbance on known maximum absorbing wavelength, and if you do little bit variation with respect to concentration by knowing the concentration, if you do little bit variation where concentration is known to you, suppose you are performing a calibration curve method over there and you are preparing the standard solutions to prepare the calibration curve. So little bit variation with respect to concentration, that small variation it will be imparted in your result, tells me the method is sensitive or not. So small difference, small variation, whether it will be able to detect that with the signal is termed as sensitivity. Whereas this particular term is always made confusion with another term which is given as detection limit. Detection limit is the lowest concentration that can be determined by the method. Okay, sensitivity is you are doing variation between 0.01 molar and 0.012 molar. So that particular molar concentration, smallest variation, does it shows me change with respect to the signal based on an instrument, that is the sensitivity. Whereas detection limit is lowest concentration till what I can able to get the readings. Robustness, yes, This is the very much new term to you people, as it measures the capacity to remain unaffected. That means like your buffer solution, where small change with respect to pH, it adjusts and remains the same. Buffer solution maintains the small variation in pH of the solution. Similarly, robustness is the term which is utilized when you do very small variation in a method and still it is unaffected with the capacity of measurement, like organic solvent, pH, ionic strength and temperature. Ruggedness is the another term utilized in correlation with robustness. Ruggedness, this particular term defines me what? It is the degree of reproducibility of the method under variety of conditions, like different laboratory, different analyst, different instrument, different lots of reagent. I'll take a pause over here. Different laboratory, you might understand, you can compare with different colleges, different states, different countries, different analyst. In the same way, you, your friend, your first your grandpa or the neighborhood who is performing after 10 years, different instruments. The manufacturer will supply different colorimeters in different area throughout the India, abroad. So the instrument will, basic principle will remain same, but the instrument will show variation, lots of reagent. Means the supplier who supplies the chemical to your lab, this supplier is different. Elapsed assay time of performance of method. Different assay temperature variation with respect to season when the experiment is performed and different days. So these are the n number of variation. Even though if I do, I can able to produce the result, test result, that is the ruggedness of the method. So whatever experiments you have performed till now from your 11th standard, I can say that all these methods are having good ruggedness. They are reproducible every year by every batch of the student. Yes, scale of operation means this particular term tells you what? That if I apply a particular method during the analysis, how much was the concentration that can be detected by the method. So different methods are there and different methods have different limitation with respect to detection and concentration of the sample. So if only a single component I want to determine, I need to check out how much of the amount of the sample available to me, then which method I can choose. If it is very small amount, I need to go for instrumental method, where without degenerating the sample, whether it is possible for me to do the measurement. Like here, when we are taking the word without degeneration, like for example pH, conductance, potential, in these all measurements you are not doing any change with the sample, measurement of absorbance, but when you add some reagent, the sample is converted into another component. Okay, so scale of operation tells me whether the sample is there, 1 gram of the sample, where analyte which was detected is 1%. If this is the amount, and if I chose the method where 1% of the sample is only detected, I should not follow the method. If I pick up 0.1 gram of the sample and 10% of the analyte is detected, I should go for the next one, where the amount of the sample required is very small and the amount of the analyte detected is 100%. So I have to go for major, minor, stress and ultra stress analysis methods to choose the final method for analysis. So while selecting this final method of analysis, I need to take care of all these things, that what is the method, what is the equipment I am taking out. Does it require major significant operating training? That is, for example, AS cannot be means the bigger instrument, you need to do some training and then only you can able to operate those instruments looking at the cost of the instrument. Similarly, I need to take care of the time factor. How much time is required for the analysis to carry out for the single sample analysis and the cost of the analysis. So once the solution, equipment and the number of samples, if everything is ready, like when you enter in a lab, the lab assistant makes ready the apparatus required for your today's experiment, the solutions for the today's experiment, the concerned teacher was there to direct you, to give you the protocol of your experiment, and if all things are at place, the time required for your analysis become, yes, time required for your analysis become constant or same during the performance. Okay, and cost of the analysis, this involves the cost of the instrument, that is maintenance cost, reagent utilized, the person who is performing this particular analysis, the hiring capacity, and the number of samples that can be processed in an hour. So looking at all these factors, we need to make the final choice of the method where small amount of the analyte can be performed with a greater precision. The minimum cost is maintained and analysis time is also decreased. Selecting specific method with careful balance between all these criteria makes the final choice as your method comes out as the best method with more accurate result. So the need of the result is urgent in most of the labs, like clinical labs, where time may be the major factor increases, and analysis time become a critical factor in case of clinical labs. We all aware during this pandemic situation that if we want to analyze and want to know the details of a particular disease, we have to do the clinical trials, which will take some more time to conclude the final inference. So the best method is often detected with the sample properties. So developing the procedure after selecting the method. Once you develop the procedure by selecting a proper method, this method should attain all the factors like small interferences, it should have that ruggedness, selecting and calibrating the equipment. Whenever you utilize any equipment, you all take care, you have to take care that your method instrument should be calibrated. You have to check out whether it is giving me the good proper result for the standard way. Like for example, pH meter standardization, where you put known concentration, known pH of the solution, that is 0.05 molar potassium hydrogen phthalate, whose pH is constant, that is 4. So when you dip the pH electrode, if the instrument is showing the same result, then yes, I can go for further procedure. So the standardization for the representative sample which validate your method. Yes, so calibration and standardization, these two factors are very important when you do the analysis. So calibration of the equipment, the glassware which you are utilizing, the balance which you are utilizing, these all equipments and glassware should be calibrated. So you have to learn the process of calibration of simply the glassware, where I just want to give over here the hint that simply you can calibrate a burette where by using water, density of water is 1. So the mass and volume becomes same. So if you wash the burette and fill the burette up to 0 mark, if the content in the burette is, if it is suppose marked 0 to 25, you take pre-weighed beaker in which you will drain the solvent water from 0 to 25, weigh that on a balance which is calibrated, and if it is showing me exact 25, then your burette is calibrated. If it is showing less or greater than that, you have to consider this error during your analysis. And standardization, just now I have explained that you have to standardize all the instruments for checking out whether they are giving me the signal properly for the known solutions. Sampling. Once everything is set, equipment is set, method is set, the solutions are set, you have done the calibration, standardization, you have to do the sampling. Suppose you are working in a big company and the samples which are coming to your company are in containers, then you have to think that how should I collect the sample as it represents the whole material. So if it is liquid, you can pick up from any part. You have to shake it well from top, bottom and sideways, mix it well, and you can utilize that as a sample. If it is solid, you have to cake and cone method. That is the method where consider your solid sample as a circle like a cake. So cake and cup method, you have to cross it like all the triangles and randomly pick up any 2-3 triangles, mix it well, and you can take out some part of it as your sample for your method. So sampling errors cannot be detected, as you have to check out that sample should represent the whole material. Biased or non-representative sample and contamination in the sample, these are the sampling errors which can lead to significant errors. So it is very important to realize that sampling errors are completely independent upon the analysis errors. So if you pick up wrong sample, that is not the mistake of analysis. Okay, so you have to repeat it again. So as a result, sampling cannot be corrected by evaluating reagent blank. So you have to learn properly depending upon the state of the sample, gaseous, liquid and solid. There are various types of methods of sampling where we can go for it and find it out the proper method so that the sample can represent the whole material. Validation is just the evaluation with respect to precision and accuracy, which will ensure that the written procedures have sufficient detail during the analysis, and it has utilized the standard sample, it has done the replicate analysis, it has been done with intra-laboratory, inter-laboratory, and all the results are compared and validated, and then the method is made to public to do the analysis. Protocols, this is simply the protocol, like you have to follow the protocol while moving outside right now, that you have to wear the mask and wash the hands and taken care of 6 feet distance. Like this protocol is for this particular situation. Here the protocol is set up stringent written guidelines specifying an exact procedure that must be followed if results are to be accepted by the agencies specifying the protocols. So it also consists of the instructions regarding internal and external quality assurance unit. The internal quality assurance unit includes the steps to ensure the analytical work, whereas the external quality control unit involves the procedures of the laboratory to be certified by external agency. Hope you have understood all the terms utilized under the heading of parameters of instrumental analysis. Thank you. Please like, share and subscribe my channel.